My name is Justin Knopfmacher, and today I will be talking about why Rust should be replacing both C and C++. And you're thinking this is probably quite a controversial topic, but honestly, it's far less controversial than you think. Let me first explain why C and C++ are no longer suitable in this modern era of development. They were designed for a completely different time, back when computers were only single processor and could only do low-level language manipulation. They were not designed with concurrency, parallelism, or distributed systems in mind. They were not designed with security, reliability, or maintainability in mind. And they were not designed with modern software engineering practices in mind. These languages are purely manual memory management, which is so error-prone and tedious. And it lacks many of our expected modern standards from programming languages, such as generics, iterators, and algebraic data types. And although there have been some improvements to both over the past decade, these are essentially just syntactic sugar and don't fundamentally change how these languages work. It's crazy that C, which is a non-loop language, is still in such wide use. And with functional programming techniques and declarative programming becoming the norm, these languages don't support the needs of modern devs. These languages are relics of the past and need to be put to the grave. And this has been an opinion that's actually a lot older than you'd expect. This is a research paper from 1987, already trying to find some alternative to C++. Then here's a bit of an article about D, a replacer to C++, and then someone saying, oh, could Java replace C++? And then again, and again. So it's very clear people want to get rid of these languages for a long time. Okay, well then why would Rust be the solution to this? Why Rust of all these other languages that I've tried? Well, to know for a good language, let's look how much it is loved by the form of people who hate and complain the most about coding languages, Stack Overflow. This is their annual survey for language preferences from 2022. And if you look right at the top, there is Rust. 86% of respondents said they loved it. So where is C and C++? Well, you kind of need to scroll, and yeah, there's C++. Only 48% of people said they loved it, which means majority of people actually despise the language. And well, C's even off the page, you can't even see it. So it's very emotionally clear why people want to use Rust. But what about in practical terms? So here's this guy on Twitter who says, it's time to start halting any new projects in C++ and use Rust for those scenarios. Okay, so why do we care about this random person? I could myself say I want to move to Rust, but I've got no authority. I've only done 6-month course on it in honors. So why do you listen to me? Maybe you shouldn't, but maybe you should listen to this guy. This guy happens to be the CTO of Azure. So I think he's got quite an authority here. His decisions will actually fundamentally change the way programming is defined in many ecosystems. And Rust is not just conceptually in use. It is already being used in AWS, in Windows, in Dropbox, in NPM, in Facebook, and it is finally the second language in the Linux kernel after C. So it is clear that Rust is slowly but surely replacing C. So why is Rust so great? Why do people like it so much more than C and C++? Well, in order to see that, we have to understand why C and C++ are so horrible and terrible. The first aspect that's probably the worst of these languages is memory safety. So in 2019, Microsoft highlighted that 70% of security vulnerabilities stem from memory safety issues. And then the same in 2020, Google found the same in Chromium. So that's quite severe. Whereas Rust doesn't have memory safety issues. Memory safety is ensured at compile time through ownership mechanism and borrow checker. Each value will only have a unique owner, and when that owner goes out of scope, the value is automatically deallocated. There's also no such thing as a null pointer in Rust, so no more null pointer errors. And each value can either have multiple immutable references or only one mutable reference at a time. Okay, so that's a bit of jargon. I mean, really, what does that actually mean? That means no dangling pointers, no data races, no need for manual memory management, and there's no runtime overhead of a garbage collector either. So it really is the best of both worlds. You both get the memory safety of Java, C#, and Python, but also the control levels you need from C and C++. So let's actually look at an example of memory safety. So this is a very basic C++ code. We have a function here called foo that returns a pointer to a local variable called x, and you see it And because it's returning a pointer, you actually, what will happen when you run it? That's undefined. You actually don't know what will happen because C++ doesn't have any way to automatically realize that there will be a problem. So you will end up getting undefined behavior at runtime. Whereas you recreate the exact same code in Rust, as soon as you hit build, the compiler already gives you an error, and the compiler tells you immediately what the issue is, where it is, and how to fix it. It should be noted that finally C++23, released literally last year, added something similar. But this is very new, and they obviously was inspired by how Rust handled it. Okay, so why not just use a language with a garbage collector? Because then there are no memory safety issues. Well, the thing is, why are we still using C and C++? There are obviously still reasons that you need to have that low level of control. You need to have that. You can't have that overhead when you're working on system critical things like, say, kernels or drivers or networking devices. So this is why Rust is very important. So let's look at another example, data races. So in most modern languages, you will probably run parallelism declaratively. But to prove my point better, I'm doing an imperative example. So we have a counter that is a public variable, and we have a function called increment. In the increment function, you literally increment the counter like 100,000 times, and then we create two threads, both calling the same function. So you'd expect this to, because it's a public variable, you should have 200,000 as your final output. And you get that sometimes. But then other times you get that or that. And like, if you get that output, you actually don't know what the issue is. You will have to go and manually look in your code because there's no errors. There's nothing telling you where the issue stemmed from. Whereas you try to do the same code in Rust, once again, the compiler comes to the rescue and it tells you before you can even build it, this is going to be a problem. This makes it very easy to trace the errors, which you just can't do in C and C++. So another great feature of Rust is the concept of variables are immutable by default. So what does that mean? That means that code is clear and simple. There are no surprises or hidden changes. There are fewer bugs and errors, no unwanted side effects or corrupted data. It also allows the compiler to optimize the code better because it knows what the value will be all the time. It can never change. And this means concurrency and parallelism are also far easier to implement. And if you need something to be mutable, you can still use the mut keyword. But this is a very intentional choice. So when you make it, you are like very aware of it. Whereas other languages, it kind of happens. You're not making this conscious choice. This is forcing you to write significantly better and safer code. So another great feature of Rust is functions as first-class citizens. So what does that really mean? It means that functions can be treated as any other values and can be passed in as arguments or saved to variables. So, okay, where can that be great? Well, in this example here, if you're using something like an iterator and a map statement, I've created a little function here called square, takes an x, and returns the square of it. And you can see how I can cleanly just put the square in the map, and it just works. This will run. This looks basically like Python in terms of like functionality, and it's very simple, easy to read. However, try to recreate this in C++, and it's a bit of a mess. Like, because C++ functions are not first-class citizens, you can simulate it kinda, but this is very verbose and complex, and like really, like I wouldn't want to read that. So another amazing feature of Rust is cargo. Everyone loves dependency management, I'm sure. So I'm sure you love it when there's no such thing as a standard package manager for C and C++. Well, cargo's here to the rescue. Cargo can manage dependencies easily with command and semantic versioning, and it creates a lock file for reproducible builds with exact dependency versions. And it can simplify dependency management, building, and testing, and ensures consistency, convenience, and reliability in dependency management. These are things C and C++ wish they had. So, okay, you're thinking, wait, Rust sounds great, but that doesn't matter. Everything's built in C and C++, too long to convert everything. Rust also has a solution for that. Rust has a thing called the foreign function interface. This allows Rust to basically interact with C code. You can both call C code from Rust and vice versa. So this essentially allows you to sort of incrementally reformat legacy code. So like you can change one function to Rust, call it from C, the next thing, and then it allows for slow overchange over time, converting all this code in a much cleaner and easier way. So I've got a very simple example of how this works, almost like a hello world example. So this is from the Rust documentation. So this is some Rust code where we have to say extern C to show that we're going to be using it in C. And it literally is basically hello world. Print hello from Rust. That's very simple. Then you just add the crate to the package, which is part of Rust like settings file. It's very easy. Then here's your C, where you just define the function as an external and you call it, and you just make sure when compiling it knows where the Rust code is. And then hello from Rust. It's simple. Like you really, it was almost no effort and you're running Rust code through C. So to summarize, Rust has functions as first-class citizens, immutability as default, standard package and dependency management, explicit memory management, while also having memory safety, and it also has a foreign function interface. All of these together give you Rust. And if you're still not convinced after all of that, does C have a cute crab mascot? I do not think so. Thank you.